I don't know if you guys hear the same recording in progress, but it's always a real trip to hear a robot say that. Let's see. All right, so I'm gonna go to my 767 planar demo. So this is my light vessel. It's pretty plain. It is what it is. It's just a demo. And just as I showed before, I have the Forma plugin up. Let me just move some of the Zoom UI out of the way here. All right, so you can see I have my Forma. Okay, still unable to log into Forma. Okay, so I'll take a look at that at the after this demo. That's good to know. We need to get you up and running on it ASAP. Enter Forma URL, and so of course it's attached to our site, our project, and then of course I'm exchanging information back and forth between the proposal named Josh. I loaded the site data before. I don't really necessarily need to load it again. I've already moved my vessel into place, so I know it'll line up exactly with the site the way I want it to. Um, a couple of things I did, sorry, excuse me, and this isn't too big of an issue if you move your light vessel onto your site in Rhino. But you can see here that here's the y-axis, this green axis here, and then the x, this red sort of wine red line. So that's you can see where the 0, 0 point is, where my cursor is right now. And so my light vessel is pretty close to that cursor. The reason why is because again, I centered our site in the Forma model. When I brought the Forma model into here, then suddenly it was centered around that 0, 0 point. And I moved this into place on our site. You can see that it's our site sort of straddles, um, basically sort of straddles that 0, 0 point, right? So if we had a second box, it'd be over here. Third box would be here. Fourth box would be here, perhaps with some courtyards in between. That's one of the reasons why you might not get good analysis of your models if it's way far off the 0, 0 point. But that shouldn't be an issue here. Another thing I did is I went ahead and exploded my mass. And so it exploded into a poly surface for 24 surfaces. And I'll just show you some of the things I did. So I'm looking at, these main surfaces like the top and the bottom, left, right, front, back. Those are all pretty self-explanatory. And it started as in this case, as an extrusion that was a solid. So I'm not concerned about any of these seams. Like for instance, these seams, unless I accidentally screwed something up and moved something when it was exploded, all of these seams should be a-okay. I'm not worried about those at all. Sometimes what happens is you might have a hole or just a gap somewhere where you started to trim and split, or where you tried to fill in an edge, a face here, or sort of a hole here, a gap here with a face. So I'm just going to show you that really quickly, some of the tools at your disposal. Because what I did is I went through and I basically just rebuilt quickly each jam and sill for each opening one by one. It didn't take me too long. I just want to show you the tools at your disposal to take care of this as quickly as possible. So I'm this is the surface creation tools, and basically I'm going to that surface button and clicking and holding until that set of tools pulls out. And you can see that there's a lot of different ways I can create surfaces in Rhino, right? We talked about a few. Here's surface from planar curves. Here's surface from 2, 3, or 4 edge curves. And you can see from the, hopefully you can see this on the, oh, sorry, I guess that's just zooming in on Rhino. My cursor here, you can see that it's a blue surface and then each of the 4 edges around it are highlighted in white. And what that means is that if I click this, I can pick 2, 3, or 4 edge curves, like let's say that one and that one. And then when I right click to enter, it added that surface for me, right? So it filled in a surface in between those. Um, so I can do the same thing here at the bottom. Click, click, and right click. And Now I just need to fill in the sides. Now the sides aren't one, two, this would be one, two, three, four, five, six sides. So that's not going to work. So what I'm going to do is, again, this was cut with a planar component and trimmed and split and all that stuff. And so what I'm going to do is I'm just going to use surface from planar curves. And I'm just going to go around and just select all those edges. They're basically the edges of all the adjacent surfaces until I get a closed shape that's planar, and I hit enter, and now it's filled that in with a planar surface. So those L shapes and T shapes that don't lend themselves to so easily to this two, three, or four edge curves, if you used if you followed the rules and you used a planar surface to cut these things, you should be able to go around. You can see I'm just literally going around the edges there until I have a closed shape, right clicking to enter. Right. And then the last thing I would probably do with this is I'll select all of these four new surfaces that I made and I'll join them together, make sure that there's no gaps and that they can be joined together. There we go. Four surfaces joined into one open poly surface. I like the sound of that. And so if I could do that, the same thing with this one and the same thing with this one, then I can sort of I can easily just select everything again and then join it together. It says it's into one closed poly surface, so I'm happy. Now, if that still isn't working, cleaning up and just sort of auditing the file, making sure that the surfaces are all sort of manifold. The last thing I did is I exploded so that they're all separate surfaces. Then I went to dir, which is short for direction. I just typed that in the command line, dir. And it says select objects for direction display. You can see that I changed my background to an off-white, like just a very light gray, and that's so I can actually see the white arrows a little better. And they're all pointed outwards. And so in this case, maybe I'll just say, if all out is not working, maybe I'll say flip all and point them all in, hit enter, and then join them together, right? But eventually, after I did that, I was able to bring it in and it looks just fine. It looks easy peasy now. I'm really happy. You can see it when I view the results. It looks the way you would expect it would, right? Again, it looks like a solid manifold objects. And walls and ceilings have thickness. You can't see through things. You can see this fin, this vertical fin I put out here, um, actually prevents some of that northwest light from coming in. It also acts maybe as a bounce, a scoop, a light scoop to get some south light and bounce it in to the interior a little bit from a different direction. But anyway, now I can start to get in the inside of this thing and start to understand if I have any huge problem areas. And it looks pretty shady in here, so I don't think I have too much to worry about, right? Um, Overall, if I opened up this whole south face, then I would have some real issues here. You'd see the floors and the walls getting really yellow, meaning that there's maximum sun exposure, direct sun exposure, just like the outside does, right? And so the outside, we can withstand that. That's what the clothes that we put on a building are for, right? And that's why we think about insulation and R values, air gaps, thermal breaks to prevent thermal bridging. Is all so that we can contain the temperature on the outside and the temperature on the inside and maintain a significant difference in our case in the Mojave Desert. The inside will be comfortable and the outside, even if the outside is 108 or higher during the summertime, right? Right now it's about 108 today, but of course we know it can get quite warm here in the Mojave Desert. 108 just scratching the surface sometimes. All right. So I was able to do that. I was able to do one really quickly for December. That was the one I just showed you was for June. December, the sun is lower and it rises and sets in the southeast and southwest. So this west side is really in a lot of shadow most of the time, right? The south face, part of the east face or southeast face, really, and the top faces are getting a lot more sun. When I zoom in, here's not maybe a big surprise, but we actually get more sun during the wintertime inside some of this south opening. And that's because the sun is lower. And so the sunlight can actually penetrate deeper into the space because of the angle that it's at, right? So um, if I think about this in elevation, right? And if the sun's angle is this, right? Then I can project this and where I have an opening, the sun only comes in that far. When the sun's down here and the angle's like this, suddenly it comes to that opening and we get a lot more sun inside, right? So, and that can actually work to your advantage, right? Sometimes, depending on your elevation and the situation, the program on the inside, maybe you want a little bit of internal heat gain and some internal heat loads in the wintertime. You might save on heating bills. Whereas in the summertime, you want to keep things cool and shady as possible, right? So again, we can learn a lot by just looking at how others have built in the deserts and other hot, arid conditions for thousands of years. I think of indigenous cultures in the Western United States and Mexico and the Americas, basically. I think about cultures in Northern Africa, the Middle East, parts of Asia, even parts of Australia. So certainly there's lots of ways to build in the desert pre-air conditioning, and we can certainly learn a lot by just simply doing better, sort of being smarter and more resourceful with the shapes and geometries that we use in the desert, I think. All right. So that's just showing you some quick sun analysis, and I'd like for each of you to start that process. Maybe then you start to think, well, maybe I need some horizontals here on the south side if you have lots of openings, or maybe the north, maybe you need to shrink that gap if you have something on the top, or east or west, right? Simultaneously, you can also run other things. Here's a daylight analysis, just show you the result. But the daylight analysis is just showing you the potential for each of these faces for how much daylight you could potentially borrow if you made an opening, how much daylight you can get in. And so you can start to see that there's some potential here in some places, right? But, we're getting some from the south, we're getting some from the top. You can see we're getting some from the west. Not a huge surprise. But really, without any tall neighbors around us that are close by, we have a lot of potential along our south, east, west, and top, even parts of our north side, our north face, to bring in daylight, right? North is the classic place you can bring in lots of daylight, and most of it's indirect because the sun only rarely sees, a little bit of northwest and northeast light in the summertime. But suffice to say that there's ample opportunities as long as you can bounce it, control it, separate that height, the heat from the light, either through vertical baffles or horizontal louvers or deep inset windows or balconies or things like that. Again, thinking about your vocabulary of planes, how do you begin to work with that? You slide a plane outwards, or do you slide a plane over? You push a plane in, etc. You can begin to fine tune your light vessels now for the particular place and its climate. Um, Same thing with microclimate analysis. So microclimate analysis looks pretty lame right now because there aren't many neighbors around. So if I go to June and I think like, let's say 3 p.m., and not a big surprise. It's barely a little cooler here on the east and north sides, and of course, it's pretty scorching hot everywhere else all around, right? Now, if I started to add more of these boxes, more of these modules, and started to add more building, then, if I started to have outdoor spaces in between or outdoor spaces that are covered, or shaded partially by the building, then we could start to create, basically courtyard microclimates, etc. Right? So right now, this is pretty much a dud. It doesn't tell me anything I couldn't have guessed rather easily. Let's look at wind, right? I did a wind analysis. And so first and foremost, it gives you a very quick thing. This is a real-time prediction of wind conditions. It's basically machine learning, learning from about thousands of simulations. So it's estimating, it's guessing, but it's an educated guess based off of looking at like a huge data set, right? That's what AI does. It's learns. When we started to shift and think artificial intelligence, we needed to make machines that could learn. Then suddenly it was all about data sets and trying to figure out, where do we get enough data to actually train these things. So here you can run thousands of simulations each, and then actually input those in as data set to help train the model to do things much more quicker and without as much computational oomph. You can see how quickly it did it. And then you can submit for a detailed analysis that'll run on their servers. So it's not like you don't hear your machine like slowly melt down like in back in the old days when you try to do this stuff. So here's my building. Here's the wind analysis. You can see that there's a little more granular information here. And you can, of course, here's the wind row. So you can see the predominant wind of our site comes from the northwest. Probably does that for autumn and winter. We have some southwest wind. We have some north and some northeast winds, occasionally some southeast. Very rarely does it come from due west, um, some from south and some from east. What's interesting about this is when you actually want to read this a little clearer, right? Like the way the graphics are um, actually quickly communicate the information, the data is important. So when I think about computational fluid dynamics and looking at wind simulations, I think about the streamlines, right? And we can turn those on and then up their density, and we can begin to see just how wind actually reacts through the downtown area, depending on which direction it's coming from. So we can start to see the where the nearest obstacles are, how they begin to influence the fluid dynamics. We can understand that actually, if our goal is to bring some northwest breezes in to cool things down, then we might need to actually have a scoop at the top that sort of brings in some wind down into the building from the top, because you can see that otherwise these things are we're in a kind of a dead zone when it comes from the northwest. Now, if we come from the southwest, again, there's different opportunities here. Let's see. Importance. There we go. We can see that again, we're not getting as much at street level, except right along the street. The Bridger is pretty much kind of a calm area for us. But again, we can get some things. We can get some winds from the south. Um, this taller courthouse building, um, fortunately, doesn't create too much of a negative pressure space at our end. So we do get a little bit of wind from these various places. We can again look at the different directions, start to understand where and when we get certain wind conditions, right? So if one of your ideas is to harness the breeze and in some way, you can always start to turn this thing on and start to glean, I think, some pretty interesting information from it. What you notice is that again, between our neighbors to the north, a lot of times we're blocked off from from the sort of most important, most sort of a lot of the wind in different directions, like northwest, northeast. Um, Whereas the north wind looks like we have a pretty healthy dose of that coming up from over our neighbors, right? So you can always see how the dynamics change around larger buildings and other obstacles or obstructions around us. So it's really our taller neighbors, the Ogden, the D, this federal courthouse, and some of the other things that are around us, another courthouse here. Um, they're far enough away that we're starting to get some breezes through, depending on the direction, interestingly. All right. So the key thing here is that, these are analytics that normally you would just sort of see rules of thumb about and you would generalize. Now we can actually be quite specific. This data comes precisely from 100 years of weather data collected at the airports, the airport in Las Vegas and North Las Vegas, Henderson. And so, that weather data is actually public information, and this taps into it. To then again, you can give it the latitude and give it your location, and then suddenly you can start to see um, daylight hours, your latitude for the sun geometry, with the wind rose, which is important. It's called a wind rose. So the sort of the deeper the wedge, the more wind you have, right? So this is the prevailing wind. We get much more wind from the northwest than we ever do from the south or the southeast or the east. And again, I don't think that you would, I mean, I personally wouldn't anticipate um, that differently, but it's kind of nice to see sometimes. Again, the fluid dynamics in an urban area can be pretty complex. What I mean by that is that again, with neighbors, sometimes wind gets uh, what do you call it? Converges into canyons of streets in between buildings, tall buildings. And what happens then when you get more throughput in the same space, the velocity increases, right? So you start to get wind tunneling and things like that. So it's kind of helpful to know. It's color coded from light blue to dark blue to sort of talk about, I think, velocity. And so, you can see where the wind kind of slows down based on obstacles, where it speeds up, etc. Right? So again, I add this stuff just so you can sort of look and see, play around, and experiment. I think that these tools are useful, but only in the sense that if you really sort of experiment with them and almost interrogate them to sort of understand how they work, and how they might be useful for you and your ideas, right? Meters per second, let's do miles per hour, put in imperial. And of course, it gives you these graphs. So of course, you can see the faster these things are, um, right? You can sort of increase the velocity. And of course, they'll give you the average velocity, right? So anyway, some interesting things here. And if you're interested in reading more about it, you can actually look at some of the info and start to um, sort of glean, I guess, how this really works, right? All right. So these are the kinds of graphics that are really useful when you're trying to communicate to people, because you could talk about wind, but then they go like, "Where's the wind coming from?" Like, I don't understand, right? Like, where's this talk about wind coming from? You go, "I'm sorry, let me show you these diagrams where you can see that the wind's coming from the northwest. That's our predominant wind, prevailing wind, and you can see how the wind actually reacts around our neighbors and through the context." And so, XYZ, right? I'm trying to block the wind that's cold, or I'm trying to scoop some wind and use it in my courtyard, right? And etc., right? So you can begin to, again, use this data to inform your design decision making as you go further, right? And I think certainly we're at a certain place where on your first two light vessels, you could actually begin to tweak the outside as needed in order to mitigate too much heat gain, or to maybe capture a crosswind or something like that, right? Um, there's nothing cooler when you can actually turn the air off for a little while and open up some windows and kind of interesting, right? Like there's no artwork on the walls to be blown around or to be injured in some way. Uh, so let's see. So that's I just wanted to show you guys these tools, right? And again, I'm just going to the right proposal, and then dumping the geometry I want into that proposal from Rhino, right? It shows up here, and then I can go to the analyze box over here on the right, and I can do things like sun hours analysis, daylight potential, wind, microclimate analysis. You can always do shadows. Let me just show you what that looks like. Do a shadow study. Site limit is missing. Draw a site limit. Sure, why not? I'll just freehand this bad boy. 150 by 150-ish. Sure, let's hit that. So I just drew site limit. I'm just reacting to the interface. It seems fairly intuitive actually. Then I could do a matrix, or I could do a specific time. I could do equinox. So let's say March 20th at 9, at noon, and then at 3. Summer solstice, 9, 12, 15, 9, 12, 15. And I could start to change this stuff, or I can just look and see what it gives me. Export matrix. It'll be interesting to see what this does. Isaac, I think you were playing around with this and trying to figure out, and it gives you like a zip file. with some JPEGs showing you. Let's see what it gives me here right out of the box without me playing around with it too much. I don't know why it's cropped like that, but you can see, I guess, a little bit of the, how these shadows are being cast and where. And I guess they're labeled equinox 12 p.m., 15 p.m., 9 a.m. Right. Let's see. An entire model. I really wish I could just view it here and actually well, whatever. Anyway, I think there's export settings here. So you can actually say the resolution. Let's go with fine resolution. Let's go with 4K. Ooh, all right. Color configurations. I don't really care so much about that. Let's preview the shadows though and see what it looks like. What the preview looks like here. Is it thinking? Okay, it's computing really quickly. So, Gene, you mentioned like, oh, why don't I have an icon? This is all working online in Forma. And so, what's nice about that, it's easy for us to share things, but at the same time, that's why you're running in your browser. And it's nice that it's doing a lot of this computing on someone else's servers, not on your own machine. Because believe me when I say that you can occupy your machine for like a month trying to do one really cool computational fluid dynamics simulation. It would just be ridiculous. You'd be night and day double checking, making sure your screensaver doesn't kick on and run it. But at the same time, now we can do it in a matter of minutes with the server farm somewhere. So that's kind of a handy set of tools. All right. I guess that's the clear shadow preview. Okay, whatever. I guess that means you can sort of look at the shadows and see what kind of colors they're at. And I really want to like say don't cut off the west side of the site and like maybe stick with the viewport that I have, not go to top view or like plan view. But I don't know. There may be a way to change that. Preview export settings, export matrix. Well, whatever. So I'm just going to maybe if I actually drew the site to be larger, maybe then it would just sort of include everything. But anyway, I'm not going to take all of our time just screwing around with little settings here or there. If you're interested in doing those shadow studies, then I expect you to sort of again interrogate it, sort of experiment with it. You'll know more about the shadow studies in Forma than I know, right? Because you're using it for your projects. So. Um, but anyway, that's what I want to do is to sort of talk about how this becomes a really good operational tool, right? Operative, instrumental to tying data into how you make decisions and how you defend decisions, right? I think that's really important. Someone, sometimes I usually get really good reviewers, but sometimes I get a reviewer and they just think that it should just be their opinion, like on what looks good or not. And honestly, you want to be able to say, well, I understand that this doesn't align with your personal taste in aesthetics. However, it does solve this problem, this problem, this problem. It's hard to refute that, in other words, right? And in fact, if you can, again, talk about what you want to accomplish, and then you can point to some of these graphics to say, I've accomplished it, that goes a long way in having a successful project. All right. So that's the name of the game this week. I want you guys to really get into Forma. And I'll just sort of again point to the near future. What we're going to do is we're going to use Forma to collect everything from Rhino and the site together, and then we'll export it as an IFC file and bring it into Revit next week. Right. So this is also sort of the glue that ties Rhino and Revit together. I mean, there are plenty of workflows to just bring a native Rhino file into Revit, but if everything sort of lines up and is in Forma, then what we can do is we can just bring an IFC file out, and then just import that bad boy into Revit. It'll be the right scale, it'll be the right units. It's IFC, it's international, it's universal. That's the sort of universal BIM standard, building information model standard. So um, if you need to share like a file that and someone's not using Revit, you can't give them an RVT file. Um, you can give them an IFC. All right. So I'm going to go ahead and stop sharing for a moment, and I'm going to stop recording, and I'll be